All right, so as you work on these four, we are continuing solving systems of equations. But if you notice, there is a new word today, and it is elimination. Okay. Jake, if I say, give me your own definition of elimination, what would you say?
Get rid of it.
Get rid of it. Yeah. So we're going to get to X stuff out today, but I need us to review a couple of things, okay? I think this will help you with the background information so we can really do well with this. You may like this better than substitution. I feel like you might. I do, personally. So why are we doing this? Why am I giving you these four problems? Well, when I show you an elimination problem, it will make sense. But let's do these together quickly. Okay, you may need to scoot over. All right, what did we notice about the X's in this, Tyler?
One pair is positive and one pair is negative.
So what happens to them?
Cancel each other.
Right, 4x, negative 4x, those are gone. Hey, they're eliminated, hint, hint, okay? So how many y's do I have left? I have negative 2y and positive 3, so all I have left is 1y, right? Who got that one right? Okay, if you didn't, see how you do on the next one. Okay, we're just simplifying. We're adding like terms. All right, going to the right. I have x's and y's. If this helps you, do this. Negative 5, negative 9 is negative 14. All right, and y's, I have 10 and negative 10. What happens there?
Cancels.
Gone. Goodbye. Any questions? All right, last two.
Wait, would you not just put y just because? Because
Okay, what's 10 minus 10?
0.
0.
But there's no 0. I have that thing.
No, you need to know that. That's something we'll talk about. To eliminate, it's gone. Okay? Anytime you have a 0 in front of a coefficient, it's 0. Because 0 times anything is what, guys? 0. All right. The bottom two. All right, so we got x's here and here. 6, negative 4, negative 2. How many do we have?
0.
Okay, do the math. What is 6 minus 4?
2.
2. 2 minus 2?
0.
0. Goodbye. Okay, if that helps you, write it that way. All right, Nick, you're on a roll. How many y's do we have?
Y, we have 2 y's.
Okay, add them together.
6. So 6 y.
Let me go back and circle all of these. Do y'all see where I'm going with this?
Yep.
Okay. All right, last one. We have, oh, this is a good one. Let me see how you are. How many terms? I'm actually teaching this to Algebra 2 today. Who said 4? Yeah. 1, 2, 3, 4. What separates a term?
Actually, one variable.
Plus and minus. Yeah. So how many terms have y's in them? 3. Let's do the math. Negative 7. You see that? What happens here?
Cancelled.
Gone.
So it's a 2.
Goodbye. Goodbye. So all we're left with is 2y. Is there another x I can simplify this with? No, just bring it down. Good.
Good one. Good job, Nate.
Okay. Isn't it fun just to mark something out?
Yep.
Again, I think you're going to like this lesson. All right, I'm going to move on to some quick review. And really some notes. I have this in a diagram, okay? I recommend you write it. Whoa, that is really.
The diagram?
Yeah, so, yeah, won't take long. I'm gonna take about 5 minutes. This is really the bulk of the lesson here, and you'll see why. Bless you. Somebody tell me the definition in their own words, coefficient. What, that's a fancy word, Tyler.
I got you, Miss Miller. It's when there is a number and a variable.
Okay, so, but what's the coefficient? So here, let me give you an example, and you tell me.
Yeah, that's where, yeah.
Which one's the coefficient?
Oh, the variable, because it's coefficient.
What's
Or,
coefficient is 4.
if it wasn't the variable, it was the number. You're not smart.
It is the value in front of the variable. Some examples. I'm just going to write several. What's understood to be in front of this y? 1. Okay. Remember, it's understood to be there. That means it doesn't have to be written, but it's there. Okay. Non-examples, really the main one is this right here. 0x is simply what, Anna? 0. That is not a coefficient. No value. And a more in-depth example. Here's a linear equation. See the green. What form is this in? Standard form. I have 2 coefficients, 4 and 6. Negative 6. Thank you. Look at this one. What form is this one in?
It's coexistent, coefficient.
No, what form? This is a linear equation. I'm just getting y'all covered.
Slope.
Slope intercept. And remember, there's an understood 1, right? Okay, just review. That should be something y'all have seen before, right? Okay. Like terms. Let's go to the bottom. The definition of like terms are terms that share the same variables. An algebraic example is 4x and negative 5x. You can have 10y and negative 12y. Those are like terms because they all have the same variable. Yes, ma'am.
Can you put it up a little bit so I can get this
I'll do it quickly. Hurry up.
Can you move a little bit? Sorry.
Ridiculous.
Are we not taking notes?
Yeah, I just am slow at learning.
It's okay. Okay. Non-examples, I'm going to go down this way. Well, that's kind of easy. 10xy is not the same as 10y. You see how those are not the same? They don't share the same variables. Okay, 10xy, 10y. Another example is negative 5w is not equal to 5wx. Should be xw. And then lastly, some specific examples we've actually already done. Negative 3y plus 5y is simply equal to what? How many y's is that? Like terms, we can add those together. That is positive 2. Negative 8x minus 2x is negative 10x. Okay. I'll give you a second to write that down. We are doing the same thing. I'm going to give you 2 linear equations, which is called a system, right? And I'm going to say solve for what? X and Y. I'm going to show you a different way. Okay, I'm going to show you 2 examples, and I think you're going to like it better. Okay, now, can I move this? Kaylee, I'll wait. Are you good? No, it's okay. It's okay. All right.
No.
All right, write example 1. Are we good now? Okay. I understand. I get it. I get it. All right, here we go. What am I feeling? I'm feeling blue today. All right, 6.3, elimination. Jake, one more time. What does elimination mean? Get rid of. I like it.
Go and get it.
Say go, goodbye, see you later. Example 1.
X plus 1.
Hold on. Nope. Sorry. 4x plus 6y equals 32. All right, real quick. What form is that? Hurry up. Standard. Good. You're all so smart.
I know, especially me.
And also, what form is this? The second one. It is also standard form. All right, look at these 2 equations. This is called a system of equations. The directions are solve. Quick review. If you graph these on a graph, they would intersect at a point, x, y. You're about to find where they intersect, okay? That should sound familiar.
Yeah.
We're not doing substitution. We're now eliminating. Who sees something that they like? Say it louder.
6y.
Okay, I'm going to change color. Watch. Guys, 6y, negative 6y.
Cancels.
Goodbye.
Go inside.
Because 6 minus 6 is what? 0. Now, guess what we get to do?
Just turn that into 7x.
7x.
Boom.
Tyler, keep going. 7x
7x.
equals
35.
divide by
7.
7.
Makes it 5. 7.
All right.
X equals 5. I already
Now,
said that. Shut up.
Nick, find y.
Go ahead, Nick. Go ahead.
So we actually are doing a little substitution because you're getting ready to do it. Tell me.
That's where you like to put, like, replace the x variable with 5. Yeah.
Use x equals 5 to find y, which is actually called substitution. What equation should we
Let's
use?
use the bottom one.
Does it matter? No.
No.
Let's use the second one.
Yeah.
3 times 5 minus 6y equals 3. 15 minus 6y equals 3. Watch your negatives. Minus 15. Hey, what is 3 minus 15? Good. Divide by negative 6. Divide by negative 6. Y is equal to positive
Ooh, yep.
2. Oh boy. Wow. So sorry. So sorry. My fault. Hello. I'm good. How are you? Okay, that's all right. Thank you for calling. Bye. All right. So, good catch. Where do they intersect? What is my solution? 5, 2, x, comma, y. And there's one more thing I need to show you and I'm done. Sorry I didn't have this up. That's completely my fault. All right. Number 2.
The answers were right.
4, I want y'all to pay attention.
Yes, ma'am. I know it's like math. It's like you get a problem and then you figure out how to do it, and then you give us something on top of it, and that it never works. And then I forget how to do what we started out at.
Just one thing at a time. All right, I'm going to push this up. Example 2. What's wrong with the first equation?
They're not lined up.
It's not in standard form, right? It's lined up wrong. So what do you think we need to do first?
Switch it.
Switch it. So let's rewrite equation 1. 3x plus 4y equals 22. I'm going to just rewrite this one just because I didn't mean to do this. I'm going to make this negative 4y.
Oh.
Yeah, I was going to.
Come on, Tyler. What did I do?
Okay, now what do you notice? Watch the numbers. Can one of these variables eliminate?
Yeah.
Which one?
-4.
The y's, right? Gone. So how many x's do we have?
6.
Do the math. Y'all do it by yourself. I'm going to do it up here and you can check.
Why did the answer change to 61?
It didn't. That's my fault. I'm looking ahead and that is completely my fault. Thank you. Whew. That would be weird. You'll see where that comes from in a minute. What'd you get for x?
X equals 6.
All right, so find y. I'm going to kind of go backwards and go that way. X is 6. When you get y, show me. Less than 5. What'd you get?
I got 1. I got -1.
Check your math. 3 times 6 plus
No, you check it. Check it.
18 plus 4y equals 22.
I got -1. Oh, Nate.
It's +1, not sure where you get
No,
negative.
there's no. It's.
Where'd you get,
Oh, I used, no, wait, what? Because I used -4. I used the other one.
you put in,
I put it in like that.
Here?
Yeah, and I
is it
subtracted.
equal? Yeah, you'll get a negative here, 2 negatives make it positive.
I didn't, no, because I got, what? I'm just saying what I did.
3 times 6 plus -4y equals 14. 18 plus -4y equals 14. Subtract 18, -4y equals -4y is 1.
Okay, well, that's not my fault because I thought that you told us to put -4 on the top one, so I put it on the top one and not the bottom one.
Okay.
Yes, I knew, so.
Okay, I have one more to show you, and I'm gonna work until the very last second. Okay, your homework is on LMS. Let me, I'll write it down for you. No, I can't, because my recording. Can someone open LMS? Who's got their iPad?
Yeah.
Avery, thank you. All right, I'm gonna show you example 3. This is important. You're gonna need this to help you do this kind of problem. It's actually one of my shortcuts. Don't you love my shortcut?
No. Absolutely. Right.
All right, let me,
Are you wondering if it's on
yeah,
Merry Christmas.
here? What did you call it?
it's bookwork. 6-3.
Hannah?
Yep.
Yeah.
All right, look at these 2 equations. Using different variables just because in the book it is different. Now, look carefully. I've got about 60 seconds. Remember one of my shortcuts. You know I love shortcuts.
Cancel.
What variable almost eliminates but something messes it up? What is it? What variable looks super close?
T.
The t's, right? But they're both negative.
-12.
What is my shortcut? Do y'all remember?
You eliminate the 16 or the -16.
I'm going to multiply either equation by -1. Watch. All that means, please remember, it changes the sign for all of them. So now you have you only change it for one. Now the t's eliminate. Boom. Here is the work. I'm going to do this very quickly. I'm adding -6 plus 15. Sit down, Tyler.
I already wrote it.
Okay, what's -6 plus 15? 9. R is -3. And T will end up being -4. The only difference here is you shortcut for 1. Remember, you change all the signs. Homework is due Monday. It's on LMS.
Hey, why don't we have your class
Tomorrow
tomorrow?
is a B day. Y'all did great.
I might as well pretend to sit.